My mom's a loyal listener of the show.
Okay.
She started moving on to YouTube. She really smashed that subscribe
Yeah.
button.
Hi, Debs.
Hi, Debs. Hi, Debs. And she hit me up right after we did that segment, and she said,
Uh-huh.
"Oh my God, this is the best idea in the world. We should absolutely get you a film crew to
You gotta
document
love
your
parents.
life."
I love
And I
it.
think
I
absolutely,
love it.
that's just a mom's dream.
Oh yeah, I think my parents would be all on board for this. Totally.
Speaking patterns break the code. Pre-trained pod.
All right, folks. Welcome back to the Pre-Train Pod. My name is Richard.
And I'm Pierce.
Pierce, today is a really exciting day. You know what today is?
I couldn't even begin to imagine, Richard.
Today
What are we doing?
What are we calling this? Are we calling this Mailbag Day?
The
Question
listener
answering?
mailbag.
The listener mailbag. Okay, there we go. The listener mailbag. So it's our first ep. We're going to do a Q&A session with questions that our listeners have sent us in. Pretty exciting, right?
Actually, I'm pretty stoked.
This is a sign we're leveling up, you know?
This is the mark of a professional show, for sure. It's also probably the mark of the lack of infrastructure and experience doing this, because we actually gave people no guidance about what they should ask us. So anything goes. You've got the technical, you've got the personal.
We have no idea what questions we're getting, right? We might be answering
This might be a
questions
mess.
about your
This
love
might be
life.
an
We might
absolute
be
mess.
answering questions on how to cook a mean steak. You know what I mean? So, hey, everything goes. We're doing it all here, folks.
Shout out to our listeners. We hope we answer your questions.
So Deborah Freeman asks, "Here's when are you gonna come home? We miss you." Oh, sorry, that's from your mom. Okay, let's do the next one actually.
Hey, Mom, see you next weekend.
Okay, first question, right? Yo, can you guys do a deep dive on RL from human feedback? Everyone talks about RLHF like it's magic, but I don't really understand what's happening under the hood. Like, how do you actually go from human preferences to a better model? Are there fundamental limitations to this approach? Would be super helpful. Thanks. Okay, interesting. What do you think? So I guess deep dive on RLHF. Okay, well, do you want to say what RLHF is?
Yeah, I mean, I feel like this could and maybe should actually be an entire episode worth of content. RLHF is reinforcement learning with human feedback, which is basically the post-training process that we use in order to align models with human feedback. The difference in these two phases is pre-training. We're literally just exposing text models like LLMs to a bunch of text. All the text we've been able to gather online in these books, that all is ingested in the 5 to 10 trillion token range. That all kind of becomes this pre-training data. And the only goal of the model, the only thing that we're really trying to optimize for is, are you able to predict the next word given the sequence? And we've gotten really good at doing that. It feels like the hotter area of research in these frontier labs is on this post-training side of the equation, or this alignment science, which is saying, okay, at that point, the next likely word in a sequence could be almost anything, including some bad stuff that doesn't answer the user's question, formats that we don't really want to support in our own output.
RLHF is part of the post-training process. It is just one algorithm that we use for post-training.
Yeah, exactly. So I'm saying like it's in this family of post-training. And the goal of the post-training is that we align with human feedback, you know? So like,
yeah, you want it to sound like a human, basically.
Exactly. And the manner in which we do that, which maybe you can cover in more depth, Rich, but think of almost two different generated data points, right? We have something that was written by a human being, and we have something that was output by a model. And we effectively want to say, okay, we would rather give the model a reward if it's close to this ground truth human text, and we want to give it a penalty if it diverges from this human text, or if it's like far different. And then you can start getting into, you can train a model or like the actual RL algorithm to be the scorer between two different generated texts. So you don't necessarily need like a human data point for each of these. But that's kind of like the general background of reinforcement learning with human feedback and why it's useful in practice.
Let me do a little deep dive real quick, and then we can pop a stack. Because actually, I think I'll give away the conclusion. I actually think that people aren't doing RLHF very much anymore these days. I think there's like actually better tools. Like this is kind of like a thing from
like
maybe
DPO.
4 years ago. Yeah, like PPO, especially DPO, this kind of stuff. So RLHF, you pre-train a model on all the data of the internet. And once you've done that, you then build another model, a second model, that is trained to classify when a certain piece of text sounds human-like or when it doesn't sound human-like. And this second model, you actually have to train by asking a bunch of people, real humans, to generate data and to say what sorts of data sound human-like and what doesn't sound human-like. So this model is trained on that labeled data that humans generate. to then basically be a model that can evaluate, given any piece of text, does this sound human-like or not human-like? And so now the second model, which is usually called like a value function estimator, what it does is you can then plug this in with your first model that's been pre-trained on all of the data available on the internet, so that this model that you pre-trained produces text that then the other model can evaluate for how human it sounds. And then there's this reinforcement learning process where these two models are basically training each other for a little bit, where they're trying to basically almost trick each other into the one model trying to generate more and more human-like sounding data, and the other model trying to get better at discriminating, okay, when is this data actually generated by the pre-trained model or by a human? And so if you do this right, what you end up getting is basically your pre-trained model gets really good at sounding like a human and tricking the model that's been trained to discriminate when data is generated by humans and when not, to the point to which it almost sounds like it's the same thing at that point, right? And so
Yeah.
this was like the first version of post-training that seemed to be very successful.
And normally that question of tricking your reward function is seen as a pejorative, right? We don't want these
Right.
models to cheat the bounds we've been given. But actually, ironically, in this RLHF setting, that's kind of what we want, like a generative adversarial network, in the sense that if you want to encourage your models to sound more human, it cheating, if you have a good enough evaluator, is it actually accomplishing the task objective that we've laid out for it, which is trying to sound like a human being. And the other
Right.
thing too that I'll add is the usefulness in these reward functions, or these like value estimator models that you were talking about, is that it outputs a continuous score instead of just saying good or bad. And that's useful here because human sounding text, or text that is in the format that we want to, is output, right? Like one of the big developments with ChatGPT, and I think the reason why subsequent tool use models have become so useful and valuable, is because that is part of what we align them on. We align them on data that says, this is how you do a function call correctly, by giving it a JSON schema that has specific tags. Every big frontier lab and model has their own markup syntax, like ChatML is a big one. It's more popularized, but OpenAI has their own, Anthropic has their own. I think like kind of XML tags inhabiting the overall text. And because we're aligning to that, then that will let the model generate as output. And we want some, fuzzy scored function from, 0 to say 10 to be like, okay, how good do we think this current state of output is? And then in so doing, encourage the model to get closer to that over time in order to try to maximize that score.
And by the way, like, you don't actually have to necessarily train a model to be this value estimator. Like, it depends on your task that you want the model to perform. So we've been saying that this post-training thing is usually used to get a model to sound more human-like, but it can also be used in a context where you're saying, I want this model to be really good at this certain task. Like, I want this model to be really good at solving coding tasks or math tasks. In those cases, in those particular instances, you actually don't have to train a value function estimator, because you can deterministically run the code that your model generates and see, oh, does this work? Does this not work? And that is actually a way then of getting this value function, because just trying to run the code itself gives you that information. Is this code working or is this not working? And so then rather than having humans label data as working or not, you can just run the code. And whenever it doesn't work, you basically penalize the model. And when it does work, you reward it. So that's actually almost more elegant, because then you don't need to pay a bunch of people to qualitatively label data. You can just have this deterministic value function. That's kind of the holy grail. When you can get those instances, that's really nice, because then you're not reliant on human labelers, which is always a bad thing.
Yeah, or at the very least costly, and it takes a lot of time.
Are there fundamental limitations to this approach?
Mm.
Yeah, fundamental limitations.
I think that speaks to what you were saying with just it's very laborious. It takes a lot of time, costs a lot of money to develop these human
Especially with human
practices.
labelers. Yeah,
Especially with human labelers. It's dependent on the quality of the model that you're training to be this value estimator, which is necessarily going to be at the limit bounded by how big and how good that network is. It's like you're almost having to solve a sub portion of language modeling or developing a good model in order to be used as a discriminator or value estimator, which is why in part they're usually based on like similar architecture stacks, maybe a little bit different, but okay. I think that covers it.
I think that covers it. I mean, I think the last point I'll say is that the new things that people are doing, like this DPO stuff, this PPO stuff, the idea here is that rather than having to train an external model, what you can do is you can use the model itself as its own value estimator. This is kind of like the new hot take And there's a paper, I forget what the title is called, but it probably has like 1,000 citations at this point or more, that shows that your underlying language model itself is a value estimator. I think it might have been Chelsea Finn who was on this paper potentially. But anyway, so out of that grew this literature where it basically says, instead what you can do is you can then actually train, or you can continue to train your pre-trained model to, given two instances, upweight the correct one by the right amount. And by doing like a ranking approach where you continue to train your model to do this ranking of good versus bad instances, that is almost equivalent to doing this two-step process where you have to train an external value estimator. The details are a little bit theoretical in some sense. So people have been doing a lot of RL work for a while, and now this work has been merged into the field of language model development. And this was one of the sort of conclusions that came out of this, was actually that a language model itself can be used for these different purposes.
All right, Rich, I have one for you.
Okay, hit me.
I have a hunch. This was anonymous, but I think this was one of your PhD friends. Okay, Richard, give us the 60-second case for small language models. You talk a lot about them, but specifically, when are convergence dynamics and effective rank the true bottleneck versus just not enough data or not enough steps?
Okay. This is like a layup. You should just check out my paper.
It has to be 60 seconds.
This might have been a co-author. Yeah, this is definitely a co-author. Well, look, I'm not going to respect the 60 seconds. I think I'm just going to go for it. This is what I'll say. Small language models leave a lot of potential on the table. So I wrote this paper with presumably the guy who wrote this question, who's my co-author, where we basically showed that, look, if you take a small model and you take a big model and you basically try to study how do these things learn? How does a small model learn? How does a large model learn? And we look into the internals of these models and we see how much of their capacity are they using? Like how much of their potential are they actually using? Maybe a better metaphor would be to say, if a language model is a car, on how many cylinders are these different cars firing on? What you would expect is that a small model, when it's trained on a bunch of data, is basically like firing on all cylinders. It's burning a ton of gas. It's trying to get really good. But at some point, its engine just isn't big enough, right? And it just runs out of fuel. And it just stops learning. Whereas a big model has this like massive engine, this like V12, and it can just keep powering through and crunch more data. We found that actually a small model, even though it has a smaller engine, isn't even using like all of its pistons, metaphorically speaking, right? It's actually leaving some potential on the table, which doesn't make any sense because a large model, surprisingly, is actually more effectively using all of its pistons, and it has more of those to begin with. So it's surprising because the initial assumption that small models aren't good because they're using all of their parameters and run out of space is actually probably false. So that then leads us to hypothesize that there's actually, at the level of the training paradigm, some advancements or innovations that we could make to force a small model to actually fire more of its pistons more effectively. It's actually at the level of how you train these things that small models aren't as effective as large models. It's not the fact that they're just in and of themselves small. That's the problem, right? It's like something that has to do with their small size leads them to learn worse. They're just not good learners. And so how do you steer small models? I think could lead you to a world where small models actually could be much more performant than they currently are today.
I really like this metaphor that you use about being in this like Martian or moonscape where you're trying to walk around and that's your optimizer, right? And you're trying to avoid falling down these crevasses, but you don't really know where they are, and you only have a flashlight that you can see.
Yeah. This is a metaphor from like maybe 3-4 weeks ago that we discussed. Yeah.
But I do quite like it. Is your supposition that what is being limited is the fact that in this like optimizer landscape, smaller models make it more likely that you will fall down one of these crevasses and therefore leave optimization and capability of the model on the table? Or are you thinking it's maybe more of an architecture issue within the model itself, where the fact is when we talk about scaling up and scaling down these models, we're almost always talking about taking transformers and then scaling up and scaling down transformers. And it's within the actual layout of these neurons, the numerical relationship between the different values in these tensors that is causing the issue as a data flow versus as an optimizer that you then bolt on top of it. Do you have any sense?
Yeah, so let me back up a little bit. So when we were initially talking about this Martian landscape, it was in the context of different optimization protocols. So depending on the type of optimizer you use, you can use a really cheap optimizer, and you can think about this like buying a cheap flashlight from Amazon that only has a range of like a foot. And so even if you're in this like dark Martian landscape and you buy this cheap flashlight, You haven't spent a lot of money on it, but it doesn't really help you very much because you can kind of only see your surrounding 2 feet around you, right? It's not like a flashlight. Or what you can do is you can spend a bunch of money, get like some super high powerful LED laser flashlight thing that costs a lot of money, but that lets you see 100 feet around you, right? And that helps you avoid these crevasses much more effectively because you can look out not just a couple feet ahead of you, but really far ahead and say, oh, okay, well, if I were to keep going, maybe I'm not going to fall down a crevasse in the next couple of feet, but in 100 feet, I see that there's this big ravine. So let me just not even explore that space. So we were talking about this Martian landscape in that context of the optimizers. In the context of small versus large language models and how these landscapes look like, it's actually, I don't want to get too confusing here, but it's almost like a third analogy, a third metaphor, where when you have a large language models, adding more parameters to the language model basically smooths out this landscape. So if you add more and more parameters to your already large language model, it's like you go from a landscape that's pockmarked with a bunch of crevasses and ravines and stuff to a more like big valley where there is no area where you could just fall down. It's all good. Like you can just kind of like go down wherever and anything will be okay. So that's what happens when you keep adding more parameters. It kind of smooths out this landscape and makes it look really very pleasant and very easy to go down this landscape. You don't have to be like rappelling off a cliff or something like that. You can just walk down
You
this
could just
slowly descending
casually
prairie.
saunter in the valley.
You can just
So
saunter down this valley.
do we know that, Richard? Because obviously we can't visualize this landscape, right? Like we're talking
This
about
is all totally metaphorical. Yeah.
we're talking about something that's in the millions of dimensions, like not this kind of
Yeah.
3-dimension easy
Yeah.
thing, but we extrapolate from what we know and can visualize in 3 dimensions. And even the projection techniques that we can do, like T-SNE, we usually take things that are like really big parameter spaces and then try to compress them down for the sake of being able to see them. Is your observation about this, having run so many different training runs at these different scale sizes and then just watching the conversion dynamics to say, okay, if we treat this gradient descent or atom optimizer as a random walk within this valley, if you randomly walk around a Martian landscape 1,000 times or 10,000 times, you can get a good sense for how often those pot marks are in the landscape. If your optimizer is really good, maybe you'll avoid them, but like you can get a good feel. Versus if you run 1,000 in a landscape that's more forgiving, you can figure it out that way. What is behind? And then last question, I swear, and then we can move on to maybe the next mailbag. But which does it end up being in practice? Is it visualization techniques that let you try to compress these convergence dynamics down to a space that you can actually reason about? Or is it more observational prowess on some of these training runs and then watching how your loss spikes or how some of these other parameters end up going?
It's a little bit more the former. So again, the issue with these models is that you can never see the full landscape. You can't just like take a bird's eye view of the whole landscape and say, oh, aha, yes, I see that this is like a canyon here and there's a ravine here and so on and so forth. The only thing you can ever do is have this local little flashlight that you can shine around yourself and look at how does the landscape locally look like. So what you could do is you could like walk around this landscape a bunch and shine your flashlight, and that kind of like gives you an idea of how this landscape looks like. So in practice, what you can do is you can take something known as the Fisher information matrix of your loss. So basically it's looking at, technically you're calculating something that's called the score of your loss, which is basically like the local curvature, like how curvy your loss is around a certain point. You can quantify that, how curvy it is. Okay. And if you do that a bunch of times, if you say, okay, I'm going to do it over here, I'm going to do it over here, I'm going to do it over here, then you can kind of like piece together what the overall landscape looks like. You can then even like represent that in 3 dimensions where you can actually plot it on a computer and you can actually visualize that. So people do that. There's like pretty cool papers where they look at the geometry of the landscape and that's what they do. So they run these statistics, plot it, and then you can actually see these things. And yeah, what I'm saying here is empirically corroborated, but also just theoretically. And this might be maybe a little bit too pedantic, but it's in some sense it's like not that deep. Like when you have a small model, fundamentally it's an underparameterized model. So you remember from like high school physics, right? If you're trying to solve a system of equations and you have like a bunch of parameters but not that many equations, it's like impossible to solve that problem, right? Fundamentally. But then if you add a bunch more equations, and when you have number of equations equals number of free variables, then you can find a solution to that, like a unique solution to that. If it's over parameterized, it's much easier to solve this. That's basically what's going on here. So if you add more and more equations, it becomes easier to basically solve for these variables. I hope I'm not losing people here with this like 5th metaphor, but this one's not even a metaphor. This is like almost exactly what's happening in a language model. You're solving systems of equations. And so as you add more equations, you make the problem you're solving easier on yourself. Did I answer your question?
Yeah. Brilliant.
Yeah.
Wasn't my question. Ask the listener.
Yeah, it's true.
Ask the
It's
listener.
true.
But yeah, hopefully that satisfied your PhD, buddy.
Yeah, hopefully. Okay, let me pull into this metaphorical bag and let me pull up the next question. Let's see. Okay, so I need your take on the whole OpenAI versus Anthropic versus Google situation. It
Mm,
feels every week there's some new model release or API update. Okay, this sounds like it might be for you, dude. Pierce, from a builder's perspective, is this competition actually good for developers or is it just exhausting?
mm.
Hmm. Yeah, so I guess like when you've been building your startups recently, I guess the question's asking, has the competition you feel been really helpful or have you tended to just stick with one solution? Like, how do you think about this?
Yeah. It's an interesting question. I mean, I think the big labs, from what I've gleaned, seem very motivated to pursue like the whole bit about these frontier labs really striving for AGI. I actually don't think that that's just something they put on their investor deck. That has always been their goal and continues to be their goal. And then they happened to become pretty lucrative along the way. But I think in some alternative universe where OpenAI and Anthropic existed, but we never saw this hype bubble around AI and LLMs, and maybe they never cracked the code on tool calling. Therefore, in practice, they're not like as useful in professional workflows. I still think these labs would be pursuing AGI. So they're intrinsically motivated to improve these models, even if there wasn't the element of competition and even if we weren't in this competitive landscape. So I think in terms of like model quality getting better, I imagine that would happen with this competition or without it. I don't imagine that they're going that much faster because there are so many different horses in that race. Unlike competitive dynamics that you sometimes see in SaaS software, where if you have a lot of different entrants, that actually elevates everyone because of the competition. And the second that there is an absolute winner, they start stagnating R&D.
That dominates.
Yeah.
Yeah. Here's a metaphor for you, or maybe a parallel, better said. Do you feel like this is somewhat similar to the AngularJS, Next.js, React debate circa 2018, 2017 that people were having, where it kind of felt like for a while we'd solved it? Everyone was really excited about React. And then obviously since then, people are still largely using React derivatives of it, right? Like Next and maybe even Svelte, I guess, would be a derivative of React. But is that kind of like akin, would you say, to the situation we're seeing nowadays, where you think there will be one framework that really emerges? Or do you think we'll always just see these different solutions in parallel that people adopt in their own companies or little bubbles?
I think it's different from the framework case because framework seems so driven to me based on usability. What are the ergonomics of actually doing development work with one language versus another, or one framework with another? I think LLMs are a little different because they're so contingent on the data that they're subjected to, and then increasingly so contingent on the RL environments that you provide for them to operate within. On the same RL point that you were raising around, if you have code execution, you can measure that output, and then that can inform what the model then does to self-correct and then try to get better because you can actually probe its input at any given time. We're starting to see that for other use cases too, like the way that people train computer use systems to be able to interact with your computer and like actually point a cursor is by spinning up a VM with Linux installed and then teaching, basically giving the LLM free reign and then giving it penalties or rewards over time for how well it's able to operate within that environment. So we're kind of seeing a specialization of labor a little bit among these frontier labs where, yes, you obviously have to move the needle on the benchmarks. And that's important because you're not going to have a soda paper or publication if you don't achieve some given threshold of score. But I think where we're starting to see the market dynamic a little bit, and the reason why these are not just completely interchangeable goods, is I think one, people seem to have kind of this like vibe check around each model, especially developers who are using these models in their workflow. I think that biases them a little bit for what models they use in practice. And then I think the
But
second
those
thing,
change, right? I mean, like the vibe check is a thing that I feel like for a while OpenAI was winning, now Claude is winning, right? It's not like Claude models have a certain vibe. Each version of Claude has a certain vibe, but it's not like I think we can talk about a Claude style response. Like there's a Claude 4. Like Sonnet 4.5 style response for sure. There's a Claude 4 style response, but I don't know if there's a lot of continuity there.
yeah, it's a similar training regime. or like a
Okay,
single
maybe.
RL
Yeah.
environment, like the data
Yeah.
that they're doing. So contingent on how well they align it, but I do imagine that if they can keep their data set relatively constant over time, I wouldn't be surprised if the tone of Claude diverges from the tone of ChatGPT.
And it's early days too, is what I would say. You know what I mean?
Yeah.
It feels like these things have only been around like 2-3 years. As they become more established and these regimes become, and like the set of hyperparameters, the data regimes, all this stuff, the pipelines become very standardized in these companies. I could see each model having a certain style potentially of how it speaks and interacts with you. Like maybe it's because it's still like the early days that these things feel a little bit volatile, but maybe it'll, crystallize more clearly how these different models sound as a whole.
You would think so only from the POV of, again, if your data is consistent, if it's sampling from truly the same distribution over time, the measure of a good model is getting closer and closer to mirroring that over time.
Yeah, you're right. You're right.
What I'll say about the frontier competition is right now, the most interesting element of being at the app layer for my projects that are is actually playing to the different comparative strengths of the different models in some overall pipeline. So Gemini's models have a reputation for being really fast and really cheap, especially Gemini Flash Lite. It's a shockingly good model for how cheap the inputs are. And that's especially true for media. So if you're feeding it videos or you're feeding it photos, it's dramatically like an order of magnitude cheaper than the other frontier providers. I don't know how exactly they're encoding or compressing these image tokens, because in some conventional image transformer, it should basically take up the same space as the text of a comparative length. But they're doing something clever, or maybe they're subsidizing it. I don't know.
Specifically for the visual domain, I guess.
Specifically for the visual domain, yeah, but even
Okay.
for just regular tokens, it's like way cheaper than most of the other models. So if you really need to stuff your context with values, I've seen a lot of workflows now that say, okay, let's throw everything into Gemini. Let's get our result back really quickly. Let's just use that to extract the most important components of the context window that I've stuffed it, and then feed the output of that into Claude or into GPT-5 and use those,
Cool.
really slow thinking models, but hone where they spend their time based on what Gemini has fed them as output.
Do you have a pipeline set up for yourself where maybe it's like one of these like workflows? You know how OpenAI came out with a workflow the other day where
Mhm.
they can kind of show that you can take like an image, then pass that to this model, and that opens up an MCP server that's used by blah blah blah. Do you sort of internally have a workflow that you set up for yourself where when there's a piece of code and you like upload an image, you have a code base basically that kind of is sniffing like the different types of inputs and forwards that to different models for you? Or do you build this from scratch every time you kind of work on a new project?
I build this from scratch every time.
Okay.
But like some core primitives of, I have my own framework that I've been meaning to open source for doing like background daemons. It's just an extension of Mountaineer.
Okay.
Yeah, the idea there basically is it makes it very trivial. Like you add a decorator and then a couple of instructions, and it gives you a temporal, which is another framework, guarantee of durability. So even if your server shuts down or crashes, it'll restart and then pick up where you left off. So I usually build all my agent workflows with that kind of as a core primitive, where you say, one, I don't want this to be blocking of any front end code. I don't know exactly when these are going to return values. So it's a better design paradigm in my mind to say the front end is just going to wait, either pull, or maybe we'll set up some server event stream and then push data to the front end when things are done. But otherwise, the actual task itself is going to be orchestrated in this like background daemon layer. And I like that as a paradigm where, you're kind of
Yeah, that's cool.
implicitly
Yeah.
establishing like this graph, this dependency graph. And those dependencies
Yep.
themselves are different models. Some models can run in parallel if they're not blocking on the output of another model, but some of them have to, run after other ones, in which case then you just organize those and then do them whenever they're complete.
Yeah, dude, very cool. Very cool. Okay, so I want a yes or no, Pierce. I want a yes or no. Is this competition actually good for developers or is it exhausting?
Yes, I think it is. I think yes.
Yes. Okay.
I'm a thumbs up.
Okay, awesome. Like the Senate hearings where they're like,
Yeah.
Senator.
It's like, here, answer the damn question.
Exactly.
It's like that Tom Cruise lawyer scene.
Yeah,
You
yeah,
can't
yeah,
handle
exactly.
the truth.
Exactly.
So iconic.
What else you
Well,
got for
Richard,
me?
this wasn't in the mailbag, but because I'm curious now, what's your new favorite movie that you've watched? What's like a recent movie that you've been really floored by? I know you saw this Leo one the other day.
Yeah, One Battle After Another, dude. Really good. Really, really good. Fantastic movie. I don't want to spoil anything. It's also a slightly hot take of a movie, and I don't really know what else to say without spoiling it. At the level of the cinematic quality, dude, it's super worth it to watch it in VistaVision if you can watch it in VistaVision. And I'm not one of these like movie snubs who's like, oh, you have to watch it in the
It's
original
Dolby or
format. But
bust. Yeah.
I will say though that this one did make a difference because depending on the film format that it was shot in, they will just show more detail in the shots. And there's several shots that I was thinking to myself as I was watching it, if I weren't watching this in VistaVision right now, it'd be really annoying to have it cropped. And there's a really cool chase scene towards the end that would be a huge bummer if you had to crop it because I think you might actually miss a really important detail of the movie. Great movie, dude, great movie. The score also very funny somehow, like a very funny movie because of like the little things that they add. It's like the content itself isn't funny, but how they deliver it, they do a really good job with it. It's like a very well thought out, very complex movie. That's all I'll say. And it's also getting like the
Complex.
craziest reviews. Leo is probably gonna win an award for this. I'm guessing he already won one for Revenant, I guess. But this one I think is like a really good portrayal of him as an actor. Like I think he does a really good job in this one. Plays to his strengths, I'll say, as an actor. Yeah. Del Toro also really good in this movie. Anyway, I'll just leave it at that. What about you, dude? What you been watching recently?
Oh man. Plus one to Sinners. I thought that was really good. I'm not a horror
Yeah,
movie
yeah,
guy.
okay.
I really don't
Yeah,
like horror films. And the
yeah.
movie I saw with some friends. We go in the
Okay.
theater. The first scene is terrifying. The first like 4 minutes of this movie are just, shock and horror. And I I turned to Sabri next to me and I said, if this goes on for another 5 minutes, I'm walking out of this theater. I'm absolutely not watching this movie. And then it ends up being, like fun and it's very fun. It's kind of like a musical. It's interesting. So if you watch it, maybe, and you are a little squeamish to horror movies, maybe close your eyes for the first couple of minutes, but it gets better. Trust me, it gets better.
Yeah, dude, me too. I had the exact same reaction. I was like, dude, I can't do this for another 2 minutes.
Yeah, I think we have
I
the
have
same
a very low
sensibilities here.
threshold.
Yeah, we're major Wikipedia before we watch a horror
Oh,
movie,
dude, yeah.
guys.
My reaction is like, if this is scary, I'm going to the bathroom, I'm reading the whole wiki, and then I'm
Yeah,
maybe
that's
coming back. You know what I mean? But we'll see.
Same.
All right, jumping back to the questions, I have one lined up here. So someone's like, yo, Pierce, what's your stack right now for building products? Has it changed at all in the last 6 months? Very related to what we were just talking about. But do you
Yeah.
have a stack that you use?
Well, I can give my rapid fire answer, which will
Okay.
sound self-promotional because it is, but it's also true. I built these web frameworks because I wasn't really happy with anything that was on the market already. I used to be a Next.js diehard, mostly because it's React. I want to develop front ends in React, but I kind of want to develop backends in Python because I think the standard library is so extensive, and it's also what ML tooling and pipelines and data flows are usually written in anyway. So I just really like Python for stuff like that. I think it's like a much more powerful language, actually on the language level, especially now that they've introduced type annotations. You can do a lot of like really powerful runtime introspection in a way that in JavaScript, because even if you do TypeScript, it's compiled down to JavaScript before it runs. You kind of can't do in the same way. Anyway, I ended up building this web framework called Mountaineer. I use that. There's a database layer on top of it that's kind of like a lightweight ORM that's async from the ground up. There's no synchronous to it, which is what you want for database communication, even if it's locally within your own like VPC or like local network. So it's fast. That's called IceAxe. And that's honestly that's kind of my stack. That plus this daemon library that I've written. I really try to keep it lightweight. But one of the reasons why I really like the ergonomics of Mountaineer is I'm writing the backend code in Python. It generates all of the stub files and glue that you need in the front end. And then you're just writing regular React in the front end. And it's kind of these like magic functions that you can say, hey, front end, go call this backend function and get more data. And then whenever it does, it can, update some of the data views on the front end automatically for you. So you don't have to write all these like side effect modifiers with use state and use effect just to update the code. So that's my conventional stack. I'm trying to think if there's anything interesting.
I feel like someone who's non-technical would have just heard blah 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 IceAxe blah 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 demons blah, blah, blah 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 mountains.
Yeah, that's right. That's a lot of jargon. But that's my answer. The one other thing that I'll throw out, which I think is fun, is I've been majorly on this self-hosting grind recently. So all of my like core services are just hosted on like one or two servers. They're not,
And
fractured or
core
this like
core services being what
serverless.
here? Are you talking about like a VLM thing that you have set up locally, or what do you mean?
No, so this is kind of like ML stack aside. This is just like core business SaaS logic.
Oh, I see. Okay.
Basically everything ML I'll do is either a batch job in which I'll spin up a run pod because the latency doesn't really matter,
Yep.
or I'll pipe
Yep.
to modal, which is the like more serverless with a GPU attached company.
Interesting. Okay, cool. I was thinking of getting on Modal the other day, but the fact that you have to interact with it through decorators feels a little limiting to me.
Mm.
Do you have any thoughts on that? Like, how does that work for you in practice?
Yeah, usually what I'll end up doing is I'll have a separate Python library, which is just my modal distribution pipeline, basically. So it's like isolated from the rest of my business logic. And what I'll
Gotcha.
do is if I need to data share among my core code base, so like a backend service, basically, with like the front end, so like full stack, I'll declare the definitions in my backend service. I'll say, here are the Pydantic models that I want this modal serverless function to return for me. And then I'll convert that Pydantic model into an open API schema. So like a JSON schema, that's this core definition of what kind of fields, what kind of input types am I expecting to get back. And from there, I have a pipeline that then generates a new Pydantic schema or like a group of Pydantic schemas that I then just place on disk into that modal framework library.
Okay,
So it's
cool.
a little
Yeah, that makes
convoluted, but
sense.
it's basically like saying the source of truth is always in the backend code. And then I can guarantee you that only this one external package is going to be installed on the modal servers. And it's like that, again, that kind of that bridge glue is my way of saying I want to enforce that these definitions can be like portable and consistent, and I can verify what I'm going to get back. And the best way that I found to do that is just to be like, okay, I'm going to treat this modal thing just like a container runtime. I'm going to write
Yeah.
code in a library just like I would anything else. And there's some, entry point that's super simple that is in like modal's specific decorator syntax. But most of the code, I could just copy and paste those files to somewhere else and it would run the same kind of way. There's not like a ton of modal specific
Makes
stuff
sense.
other than declaring how you want to build the container.
Cool. Yeah, that makes a lot of sense. Nice, dude. Thanks for sharing your secret sauce.
Yeah, don't copy my stack. I'm kidding. Feel free to copy my stack. Okay, Richard, are you on this MCP hype? Either building things with MCP servers or using MCP servers in your day-to-day research, and or since you just finished your PhD,
Yeah.
have you found anything to be useful AI tools for actually publishing at scale?
Yeah, at the level of the MCP servers, I had a Figma MCP server I set up, which was pretty cool. Cool in the sense that I could see it being useful if I were working on a really big project. Because basically what it allows you to do is when you're interacting with your code, you can say, hey, generate, this button, and it'll then, when you say button, it'll infer that you're talking about this thing that you designed in Figma. And so if you have a design system set up, it can basically just, rather than having you to specify what that is, it can just look at that and add it to the context. So at that level, I've used it. But no, I mean, frankly, for me, I don't really get the use of it because I'm just a solo developer doing like little things now on the side. It just doesn't, I don't get the benefit from it. If I were working on a team collaboratively, like sure, there I could see it actually being very useful, I don't, do you use MCP a lot for your stuff?
Not really, to tell you the truth.
Yeah.
I think MCP is like a fantastic concept. It kind of feels like the models aren't super well calibrated to them right now. At the limit, I think models can only accept up to 40, it's like 25 or 40, depending on the model, MCP definitions at any one time. And you end up running out of context pretty quickly because, all of these MCP servers, you need to both include the like JSON schema definition of what they are, but you also need to include the hints for what you should include in the different fields and like the descriptions. And there's just so much additional context that you're necessarily taking the hit on to include every single time you start this model and you link it to an MCP server that I think I'm more of a fan of Rapid, which I've done a couple times. If there's an MCP server that exposes something that's like particularly valuable, there's this one that can control a Puppeteer instance. So it can boot up a browser and do some testing for you locally. I honestly just wrap the MCP server in a bash like make file and it ends up working better. because the models, regardless of how they're trained, know how to interact with bash and terminal commands pretty well. And it can like more or less from the name definition that I give it in the make file say like, oh, we have these even 100 different make commands. Which of these seem most relevant to my given task, given what I'm trying to do? Let me just do a man command against that, or like a help command, and then reveal exactly what I need ad hoc. I kind of like fitting them through this like bash runtime versus this separate thing of being full on MCP servers. How do you think these are going to evolve over time? Like, it feels like one of these things where there's so much interest in building MCP servers. There's so much smoke. I've got to imagine eventually there's going to be fire.
Me and you, we both basically are just working by ourselves, right? Like, you don't really have too many buddies who you're working with collaboratively right now. And I think it would be really interesting to see if your, startup scale up and you start employing, 5, 10, 20 people. Is there a point at which you have to start using MCPs to really keep up with other companies because you find it just too hard to collaborate with your front end folks, with your back end folks? There's that at the level of communication almost. MCP servers allow you to facilitate easier cross collaborations between teams. My guess is that that's probably where a lot of the alpha comes from with these MCP stuff. But if you're just doing it yourself, like a lot of these things can just be like bootstrapped.
I guess that's true. And like, where to look. I think there's a big use case here of just like, these are all kind of RAG retrieval pipelines at the end of the day. Like, MCP is used
literally
to hook into something else and search for it.
Yeah.
So if you know already where to look because you created the code yourself, you don't really need that same kind of RAG retrieval.
Yeah, I think you nailed it. Exactly. That's been my feeling. It's like, I know where to look anyway. I don't need this thing necessarily searching for it. But imagine that we were at a big company. Imagine we're working at like YouTube or whatever, right? I imagine that they have a Figma file with 200 different things. And there's a button for dark mode. There's a button for this holiday. There's this color or this color or this color. There's A/B testing, right? With this color versus this color if you're in this geographic region. So it's at that point, there it makes a ton of sense to then have your engineers just be able to say, okay, well, rather than having to interact with this designer, just tell me like, okay, so we want the button that is meant to be in this A/B test for North Dakota. Okay, I'll just write that in text. And then because I'm using an MCP server, it can do the correct retrieval for me, right? And it's, oh, okay, well, in that case, I should be using this color, this hex code. Perfect. But that is given to you by the MCP server. So that makes a ton of sense to me. But if you just have a couple of files, like maybe you're not even using best practices, industry practices for this stuff, you're not gonna have a real use case for MCP servers. That's my TLDR on it.
I think that's
But we'll
that's
see.
a good 2 cents. Okay, Richard, this one's fun too. If you were a benevolent dictator for a day, or at least benevolent dictator of kind of the ML AI landscape, if you could mandate one evaluation or procedural step for coding agents that isn't a static benchmark, what would it be and why?
Oh, that isn't a static benchmark?
Yeah.
That's really interesting. I think it'd be cool to really flesh out the LM sys So it's this open source project. We already talked about this before, but when you have a language model you've developed, it's this thing where you can then basically upload your language model as an API, and then people can log in and they're presented 2 different outputs, and then they get to uprank whichever one they think is better. So it's like this like pairwise comparison between these models. I think that's really cool. I think that that's probably the right way of evaluating like the vibe of a model. I think it'd be really cool to have some sort of a system where you don't actually have to log into LM Arena to do this, but where maybe at the level of your computer, like when you're interacting with the OS, behind the scenes, whenever you are interacting with it, it keeps track of what you're doing and where you're clicking. And your computer can maybe show you 2 different models without you realizing somehow. And that as a result of this, without you even realizing that you're participating in this evaluation benchmark, every single person with access to a computer can be automatically ranking these different models. Almost like how CAPTCHA was obviously very successful because they were able to incorporate it onto basically every single website, and then they got like trillions of data points. It'd be cool if we could do the same thing for language models, where there's some sort of a way to expose A/B tests of different models to everyone whenever they interact with their computer. I think that makes a lot of sense. And then you can then start really saying, okay, at the level of, for this type of question, we showed all of these 50,000 users these two different models, for this sort of question, model A performs better than model B, but then for programming questions, model B performs better. And you can start doing these really niche at the level of different types of tasks and different types of instructions, which types of models perform better. That'd be cool. But I don't really know if I would want to generate an actual benchmark. Like, I don't know if I would want to say, hey, we should all be using like MMLU, because that eventually is just going to be a task that will be solved, I think, you know? So I think these like dynamic things where people are voting on models, these like living tasks are probably the right solution.
I like that. Richard
Yeah.
becomes dictator for a day, and the first thing he does is forces us all to become data labelers.
Exactly, dude.
Thanks, buddy.
Honestly, I mean, well, here's the thing. I feel like the right way to do evaluation is where it feels like you're not actually evaluating, you know?
Mhm.
Where it
It's like
feels like
implicit versus explicit evaluation.
yeah, like where you are actually evaluating these models on how people use them, like how they feel, like that feeling aspect is so hard to quantify. And if we could do that effectively, then I think it makes all the other evaluation benchmarks somewhat mute, because those are testing out all these niche use cases that you might have to say, okay, well, let's create a benchmark that's really good at question answering legal text. Well, wouldn't it be cool if you could just subsume that in this like live evaluation where as people are interacting with legal texts, they're upranking model A versus model B. And so you don't need to generate an evaluation benchmark for that specific use case, because if you show this to enough people, it'll automatically be evaluating a model for that. That's kind of what I'm suggesting, you know.
Makes sense.
This one I
Yeah.
thought was pretty cool. I'll be honest with you, dude. Can I give away some secret
Yeah,
sauce?
please.
I actually wrote this one a little bit. I was just curious. I really just want to hear your takes on this one. I also submitted this one.
To be fair, there were no rules to say we couldn't ask ourselves questions.
Okay, Pierce. Here's a hot take that I have for you. I think that we are probably massively overthinking prompt engineering. And so my question is, in 2 years, are we really going to be sitting around still carefully crafting these prompts, or is that just going to be automated away? Like, as someone who's building products, do you actually spend time on optimizing your prompts, or do you just kind of feel like it's kind of like a meme at this point, you know? Like this whole notion of having a prompt engineer role at companies. Like that was a meme for a while. Do you
Mhm.
still think that that's something that's relevant in 2025?
I think my short answer is no. I don't think it's super relevant anymore, because as these models get more calibrated or more aligned with human preferences and what we want them to do, you've even seen the evolution from GPT 3.5 era to now. If you have something in your system prompt, the models usually do a very good job at accommodating that prompt. And I find that even when they don't, adding more encouragement into the prompt doesn't really move the needle on that much, right? It almost seems like some intrinsic failing of the model for some reason. Like it wasn't exposed to this given situation, or it can't generalize to this given case properly. And in that case, then I think you're probably better off doing something else, or maybe refactoring the tasks into different things. But I found the A/B testing process of kind of writing prompts to be more akin to just figuring out the overall architecture of things and following a conventional engineering approach of how to optimize that. So you start with need gathering, like what do we actually want this model to do? What's going to fulfill the business requirements? You take that, you put pen to paper, you describe it, you come up with a few examples, and then you iterate. Ideally, you have some benchmark task that you can run this thing on to get a little bit more numeric. But even if you don't, you can throw in a couple of examples, see, do these work, do these not? And most of the changes that you're going to make from there, if you are adding edge cases to the model, you're adding in a couple more examples to try to, take it from one shot to like a few shot, maybe like 10 shot with examples. Or you're saying, okay, well, we can separate out these two tasks. It's getting too complicated just for one prompt to accommodate all of these different factors that we want to evaluate. So we're actually going to say, let's run 3 different prompts that can all focus on different things. I find all of those to be just another form of refactoring, right? It's like refactoring with ML awareness of how it's performing
so-
and then what these models are capable of.
You're saying almost like splitting up these prompts into new chat histories, or are you saying, I guess, can you describe a little bit more how this is like akin to refactoring?
Yeah, basically exactly that, right? So most of the places where I think LMs are so interesting are things that happen out of band when you're not actually talking to the agent yourself. So if you do have some chat interface that you're dealing with, that's your front end. a tool call of that one given chat instance might be find me Richard's biography, right? What does Richard do?
Right.
And a naive
What do I
way,
do? No one knows.
what do you
Yeah.
do? You're lifting a lot of weight these days. The naive way to say, okay, let's just put that all in the primary chat window. So it's calling tool call, go to Richard's website. Okay, calling tool call to follow this link. Okay, calling tool call to actually like research this publication database through API. You're actually exposing the tool calls. I think we're increasingly seeing those tasks more in this purview of sub agents, which is basically your core main agent that you're having the conversation with, spawning out these really dedicated subtasks that are maybe synchronous or maybe asynchronous, but you're effectively delegating that to some backend process, which is going to do all of those tasks. And because of that, because it's not actually a chat session in the way that we conventionally think about, it's more like these different agent pipelines that you're potentially running. And in those settings, then I think the act of code refactoring, I would literally draw a parallel just one-to-one with, instead of doing things in a synchronous manner, I'm doing asyncio.gather and then calling 5 different functions that can't talk to one another, but can deliver me results separately. If you want to encode more human expertise or more knowledge or more of an opinionated design into these models, I find that usually is the best way to split up a prompt into just like smaller components and then provide a little bit more deterministic structure on top of it, and then feed whatever those end results are into like some meta model.
Yeah, it feels like these like modularization approaches is always the right thing to do in engineering. No matter if it's for coding or if you're an architect, and you're like designing a building, always what you'll want to do, and I'm no architect, but I imagine that's the same principle. You want to take a big problem and chunk it up into these little pieces that you can all solve sort of in a very independent modularized fashion and stack them on top of each other to give you this emergent complex behavior that you're seeking. Regardless of the complex behavior is building a building or building a bridge or writing some code, it's all like the same approach fundamentally. And it feels like this prompt engineering thing was almost more like a digression from that best practice for a little bit, where we were just like writing these massive prompts in one go, filling up the context history, which is obviously like very much not in this sort of spirit of modularization. But what you're describing here makes a lot of sense to me intuitively, where it's like, okay, well, we should actually regress back to these best practices and stop doing this like silly, like massive prompt that seems to be the norm for the last 2 years.
Yeah, I think it depends on the exact situation. Like if you really need the flexibility to say, I need one sole decision maker that needs to respond to this diversity of situations that I can't really foresee ahead of time as a person who's creating the system, then like you really have no choice. You need to put that all and give that one model all of the context and the ability to make all of the decisions to really act as that sole decision maker. But I think if you can inject like a little bit more of your expert knowledge, that's where that refactoring question starts to come into play. I think that the ability to communicate clearly and to really know what you want is really important. And I think is under this purview of maybe it's not a separate job or like something that people have to like train up to almost speaking the lingua franca, speaking in models' tongues.
Yeah.
I don't really think that's what it is, but I do think your ability to clearly articulate this is what we want you to do, the same way that it's a bit of a skill really for a manager to figure out how to articulate a new task to like some junior engineer. I feel like that question doesn't get enough play in school at the very least, of like, you're never writing specs when you're in some CS classes. And I think that muscle memory is really only developed like on the ground in the job. So I think that will continue to play a role insofar as LLMs right now don't really extrapolate what you're saying to anything more than just this input output. You ask for something, it gives you that thing. So knowing how to ask the question of architecture and then getting some results back, making a decision based on that, iterating, or, visually describing what you're looking for if you're talking to a Sora model instead of just saying, hey, give me Pierce hugging a dolphin, will give you a more accurate end product. And I think that element, whether you call that, prompt engineering, context engineering, I feel like that
it's all the same thing. Yeah.
It's basically all the same thing. And I think it distills down to just, okay, these things aren't magic or aren't magic yet. So figure out how to articulate that thing in a way that actually, again, is a very succinct but accurate representation of what you want as output.
Of the problem statement. Yeah, totally. I agree. Well, dude, incredible. This was super fun, man. I
Yeah,
feel like we should
a
do
good
this more.
mailbag.
Yeah. This is a pretty good mailbag. I'm actually pleasantly surprised at some of the questions we got.
Yeah, same.
I thought it was all going to be like, hey, dude, what's up?
What was that high school app where you could ask the anonymous questions to people?
Oh, Yik Yak? Yeah.
Yeah. It feels a
Remember?
little bit like that.
Yeah, it
feels
was
a little bit like that.
Yeah, exactly. Yeah, keep them coming, guys. This is great. This is super fun. Well, I think we did a pretty decent job. I hope this was like kind of useful. And if this was useful, let us know, guys. And if it is, maybe we can do this like every like other month or something like that. But we'll see. Until then, buddy. Thanks for doing this with me as always.
Yeah,
And
agreed. I had a good time.
I guess have a good weekend. Yeah. Sounds good, buddy. I'll talk to you
You too,
soon.
man. Talk soon. Bye.
Alrighty. Bye.